Good morning everyone. I just welcome all the first sem physics honorary students to physics department Digboi College. Today I am going to teach you the first unit of your C1 syllabus, that is calculus, and within that we will see at first what are limits. So let's begin. So let us at first try to understand the term limit. I hope that you have got this term limit in class 12 maths. So let us again see what is this limit. It can be defined as the function f of x is said to tend to the limit L as x tends to a if and only if the limit L is independent of the path followed by x as x tends to a. Then we can write mathematically this, that is limit of f of x as x tends to a is equals to some value L. So let us try to understand this definition of the limit with the help of an example. Consider the function f of x is equals to x minus 2 by x minus 2. So if we take f of x is equals to 2, we are going to get what? 0 divided by 0, which implies what? Which means what? Undefined. Means the function is not defined at x is equals to 2. And for other values of the x, the value of the function will be what? The value of the function for other values of x will be 1. Only if x is not is equals to 2. So this is what we are getting here. Now if we try to draw the graph for this function, it will be looking, let me draw the graph at first. So this is the y-axis and this is the x-axis. So let me write the name. So this is the y-axis and this is the x-axis. And let this be the 1. Let this be the 1. Let this be the 2. So in this way I have drawn. So if I will draw the curve for this function, it will be looking something, sorry, it has become bad. I'll be taking the help of the lines only. So it will be looking something like this. So if you see at x is equals to 2, at x is equals to 2, we are having at this point, that is the function y is equals to f of x. Its value is what? Undefined. As you have seen here, it is undefined. So this is a gap where we do not know what is the function and it is completely undefined. We can call it as void, or you can say it is a discontinuity point of this function. So for f of x is equals to 2, we are having undefined function. But what if x is approaching to 2? Then what we are going to get? Let me take the here, let me represent this with the red marker. Suppose x is approaching towards the 2 from left hand side as well as from the right hand side. Then certainly the function f of x will be also approaching towards this undefined point or the gap. So indirectly I am saying that if we are approaching, or if x is approaching towards this 2 from left hand side or right hand side, the function f of x gets limited, or we are limiting the function around this gap, or you can say the function also approaching towards the gap. So let me write here, that is limit the function f of x as x tends to 2. This will be equals to what? 1. Why 1? Because you can see the graph of this function is 1 here. So this is what the limit of the function x as x approaches to 2 is equals to 1. Let us try to see another example. Now let us take the function f of x is equals to x square. See. So for this parabolic function, we will be having a graph of a parabola. So let us do the graph at first. So let this be the y-axis, let this be the x-axis, and the graph will be what? Parabolic in nature. And let this be the parabola. So here we can see this is what? Y is equals to f of x, and this is the x-axis. Let this be the 1, let this be the 2, here let it be 1, let it be 2, let it be 3, and let it be 4. So certainly if we see for x is equals to 2 from the function, we are getting what? F of x is what? 4. Now what if I write that for x approaching to 2, find the limit f of x. So as x will be approaching towards the 2, our limit will be approaching towards the, you can see these are, let me represent this with the help of the red line. You can see this is the approach of the function f of x as x approaches to 2. So we can write here what? Limit f of x, x tends to 2 is equals to limit x tends to 2, it is x square. So x square, what is the value of the, where the x is approaching? It is approaching very close to the 2. So we can write 2 square, which is equals to 4. Now you must be wondering why I'm writing this 2, though I'm writing here x is equals to 2. So just do the calculation. Suppose I have written 1.9. Its square will be how much? If you use the calculator, you are going to get what? You are getting what? 361, that is 3.61. If you are taking it this, then you are getting what? 3.9601. 3.9601. If you are moving more closer to the 2, then the square of that will be what? It is 3.9960. So as you go more closer to the 2, or you say as x is approaching more closer to the 2, you are getting a value of the function f of x very close to this 4. Means you will be getting something approximately, you will be getting what? 3.9999 something. So that's why I'm directly writing here 2, and we are getting approximate value, that is 4, when we take the limit of the function as x approaches to 2. So this is how we find the limit of a function, and this is what a limit of a function means. I hope this must be clear. Now let us do a problem based on limits. Say that our function is f of x is equals to x square minus 4 by x minus 2. And the question is what? Find the limit f of x as x approaches to 2. So what we can do here, let us write limit f of x as x approaches to 2 is equals to limit x approaches to 2 x square minus 4 by x minus x minus 2, which can be further written as limit x approaches to 2. Here we cannot put it directly because if I put the value of x equals to 2 in both numerator and denominator, we are going to get again undefined, that is 0 divided by 0 is undefined. So here we are going to simplify it. So here we are going to write what? X minus 2 into x plus 2. This is the formula I have applied, and this is x minus 2. So this and this cancels out, and we are left with what? Limit x tends to 2 x plus 2, and we are getting what? 2 plus 2, which is equals to 4. So this is how do we solve this problem. So we can solve more such similar type of problems for our practice purpose. I hope you have understood this. Now consider another function, that is f of x is equals to, say, x plus cos x, and here you have to find limit f of x tends to 0. So let us see how to get the limit of this function when x approaches to 0. So we will be writing what? Limit f of x as x tends to 0 is equals to limit x plus cos x and x approaching to 0. So this will be what? 0 plus cos 0, which is equals to again 1. So this is how we have solved this. After having some basic idea of limits, let us try to understand continuity. So a function is said to be continuous at a point x is equals to a if and only if our function f of a is defined at that point. The second condition is that limit of the function f of x as x tends to a must exist. And the third one is that the limit of the function as x tends to a must be equals to the value of the function for x equals to a. Now let us try to understand this with the help of the graph. Suppose this is the y-axis and this is the x-axis. And let me define this curve. This is the y-axis, which is f of x, and this is the x-axis, and let this be the curve or curve of the function, okay, f of x. Suppose at this point the function is not defined. Let it be a. So if our function is not defined for x is equals to a, it means what? F of a is not defined. And if it is not defined, then the function is not a continuous one. Means for this curve, we are having a discontinuity at this undefined region, since our function is not defined at this point. So I think the first point is very clear. Now to check the existence of the limit as x tends to a, we will be taking left hand limit and the right hand limit. That is limit, left hand limit, x tends to minus a f of x must be equals to right hand limit f of x as x tends to plus a. So if we see this in the graph, we will see that this is the left hand limit, means limit f of x is approaching towards this undefined region as x tends to negative of the a, that is left hand limit, and as x tends to plus of the a, our function is again approaching towards this undefined region, and so we will be having a single value for these two, and thus the limit of the function f of x as x tends to a exists. If we see the third condition, this must be also satisfied here. Why? Because so whatever value we are having for x equals to a for the function f of x, we will be having the same value for the limit f of x as x tends to a. Here two conditions are satisfied and the first condition is not satisfied, so this function is not a continuous one. Let us try to understand this with the help of a problem. Suppose we have the question that test the continuity of f of x. So this is the function, and for this function we have to test the continuity, and this function f of x is equals to modulus of x by x provided x is not equals to 0, and it is equals to 1 provided x is equals to 0. So this is the question and we have to test the continuity of this function. So how to approach for the solution of this? So for the solution purpose, at first solution, so given f of x is equals to, at first we'll write the function in this way. This can be further rewritten as x by x is equals to 1 for x greater than 0, minus x by x is equals to minus 1 for x less than 0, and 1 for x equals to 0. So since it was here modulus, so we have divided into two parts. One is plus 1 and one is minus 1. Means, sorry, one is plus x and the other is minus x. And we have given the condition as well. When x will be greater than 0, then we will be having positive x. And when x will be less than 0, then we will be having negative x. And after simplification, we will be having 1 and minus 1. Now let us proceed further. Therefore, left hand limit x tends to negative of 0, f of x is equals to, we can directly write here limit x tends to negative of the 0 minus 1. Negative of the 0 means less than 0. So it is minus 1, which can be further written as minus 1. Similarly, if we see the right hand limit, so limit f of x as x tends to positive of the 0 will be equals to limit 1 x tends to positive 0, which is equals to 1. So here we see that limit x tends to negative of the 0, f of x is not equals to limit x tends to positive of 0, f of x. If you draw the graph of this, you will see that the graph will be somewhat like this. If this is the y-axis and this is the x-axis, so here we are going to have, suppose this is the plus 1, this is y, f of x, and this is the x, and this is the minus 1, and this is the 0. Okay, so we are going to get a curve for the x greater than 0 in this way. So here is 1, and the another x less than 0, this is the another one. So you can see the function is not continuous. This is the f of x and this is also f of x, but we are having different values. Here it is f of x is equals to what? Limit of the f of x as x approaches to positive of the 0 is 1, and here as x approaches to negative of 0 is minus 1. So this is what the graphical representation of this function. So for today I am concluding my lecture here only. In our next class we will see some more examples of continuity, and we will also see differentiability of a function. So that's all for today's lecture. Thank you.